All right. Hey, everybody. The purpose of this video is to continue our discussion about grade in class that we had in class yesterday. And to bridge the gap between yesterday's class and next Tuesday's class. I appreciate your flexibility as we set up the COCC math contest. And I think this is going to be a fine way of kind of bridging that gap. I'm also going to add, I'm not going to do the in-class quiz I spoke of. Instead, I'm going to do another out-of-class quiz. You'll see it linked on the schedule page once I get these videos up and running. So just wanted to let you know about that too. It'll make more sense after we get through these videos. So first, what we're going to look at is the basic definition of grade again, which I know we established in class yesterday. When you see 6%, that's just 6 out of 100. So that's 6 units of measure of rise over 100 units of the same measure for run. And you got to make sure they're the same measure, otherwise you can't. Otherwise the units don't divide off and you don't get the nice unitless 6%. So here is a picture of a truck going down the road with a 6% grade sign, and that is exactly where you often see these signs, is on big mountain passes where you've got multiple miles of road all cut at the same kind of grade. I'm going to go to band practice on Saturday over in Corvallis, and there's one of these signs right over, oh man, what's that pass? Right as you drop onto the crappy part of Highway 20. I forget the name. Not Sandy M. That's the early one. There's a second one later on that's got it's like by like Cemetery Hill or something like this. Anyway, doesn't matter. There's one of these signs. So what I wanted to do first was I know we talked about College Way in class, and this section of College Way is indeed 6%, just like that last sign we saw. What I want to do first is I want to talk about the angle that's formed by the road in this section. Now, I only measured this section of it because it was pretty uniform right here, and you'll notice that on certain roads they vary quite a bit. We'll deal with that in the next video. But in this section right here, it's a 6% grade. What's the angle formed? Okay, now measuring the grade of this is challenging, and I'm going to get into that too when we talk in the next video. But the angle formed, I'm going to show you the old school way of doing it, and then later on I'll show you the newer school way of doing it. The old school way involves us cracking open a web browser and searching for something called a tangent table. A tangent table, and I'm going to do an image search for tangent table. Let's take this first one and see what it looks like. That looks fine to me. Yeah, this is a NASA web page. We can live with a NASA web page, I think. And what this does is it shows you a list of all angles from 0 up to 90 degrees. I don't know what the point zeros are for. 0.0, 1.0, 2.0, all the way up to 90 degrees. And then the corresponding tangents of those angles. Now, tangent is a word that we're going to refer to every once in a blue moon in this class. But for right now, here's all you need to know. A tangent is another word for the grade. So an angle that has a degree measure of 0 has a grade of 0. An angle that has a degree measure of 1 has a grade of, now check this out, it's 0.0175. Grades are often given as percent, so that's 1.75%. Remember, move the decimal, boop, 2 to the right. 2 degrees, 3.49%. 3 degrees, 5.24%. One of these we did in class yesterday. I asked you what angle had a 100% grade, and that would be this one right here. And we figured out eventually it had to be a 45-degree angle because that has the same rise as run, which would mean it has the 100% grade. So this is just a listing of all the degrees by whole numbers with their corresponding grade measures. Now, College Way, if you look back at College Way, it has a 6% grade. And if you look at this chart, you'll notice that there is no exact 6%. There's 5.24. And there's 6.99. So for this class, I'm not looking for scientific precision for something like this. We can just say it's between 3 and 4 degrees. 3.5 if you want to give a decimal value. If you need more precision than that, there are tools to get more precision than that, and they're not part of Math 105. But just as far as getting the angle that's formed, it's somewhere between 3 and 4 degrees, and that gets us in the ballpark of what College Way looks like. Cool. Hopefully that makes sense. And we could refer back to that table in a second too. Flip these. Okay, let's keep going around Bend. The next road I have a picture of here. This is, if you're familiar with the northeast side of town, this is actually Archie Briggs Road. Archie Briggs, it varies quite a bit depending on what part of Archie Briggs you're on. I measured the steepest part, which is the switchback right here. This is part of my commute every day. And that steepest part is 16.7% grade, that little steep part right there. This is actually part of the Cascade Cycling Classic every year. It's pretty amazing how burly steep that is and how it makes your legs feel. So what I want to do right now is I want to come over here and look at our tangent table again. And 16.7%, well, there's 15.8, and there's 17.6. So it's somewhere in between those two. So maybe call it 9.5 degrees. That's probably good enough for government work, as the old saying goes. Good enough for government work. So I'm going to stop with the angles now, because there is actually, I've got a better way of doing angle measures, much more direct for you and actually much more precise. And I'll show you that in a little bit when I show you the Excel calculator for the first time. Next road in town is Juniper. This is 1 block east of College Way. As a matter of fact, it starts and stops at roughly the same elevations as College Way at this point, although it's a little bit higher at the top. But it does something very, very interesting. If you took a right, if you're going westbound on Newport and you took a right onto Juniper Street, this is almost completely flat right here, the first block. And the second block ramps up. If you've ever gone eastbound on Portland, in Bend and look down Juniper, it looks almost like you're going down a sledding hill. Turns out that part of the sledding hill is 17.7%. It's a very, very steep hill. Very, very steep hill. Very dangerous. As a matter of fact, I had a student who lived up here one year, took Math 105, and when I used this, she said, "I dare you to ride up that hill." So one day I did, knocked on her door and said hi, and then went to work. But yeah, 17.7% is very, very steep. You wouldn't see that on a mountain pass. It's too dangerous. Or at least not a mountain pass around here. Here's another ridiculously steep hill. This is Iowa Street, which is over it's kind of near school, actually. When you're in class with me, you're very close to Iowa. If you're in my office, you're exceptionally close to it. You're actually within a quarter mile of it. If this is looking, I believe, westbound on Iowa. So I just came off of 12th Street and then took a left on Iowa. They actually close this section of road in the winter. Here's another look at it. This section gets closed in the winter because it's just so steep that if it gets snow covered, you can't stop. There's just too much forward momentum and not enough friction. I'm not going to tell you the grade of that one because I'm going to have you calculate that one later on your first exam, which I'll have posted for you next week at some point. So you'll have a good time with that. But you can see by looking at the house how there's house here, but if you go horizontally across, you run out of house on this side. There's you see this a lot in Bend, houses that are built into the sides of hills. It just so happens this hill also has a road going down it. So that's a little tour of Bend. There are other steep roads in Bend. Palisades, for example, is even steeper than this. But you get the idea. These roads all have their own grades. Let's visit Europe. This is a shot from the Tour de France, which I've stopped watching over the past decade or so. But still, nonetheless, I appreciate these wonderful mountain passes that the bicyclists have to negotiate. This is Galabert Pass in the Pyrenees, which is only 7.1%, and I put only in quotes, only 7.1. That's not much steeper than College Way, and I ride College Way every day, and it's nowhere near as steep as Archie Briggs, and I ride Archie Briggs every day. Or every other day. So what's the big deal about this race? Why is this race so hard? Well, what this doesn't tell you is the fact that they go 7.1% for like 10, 12, 15, 20 miles. And they're doing it at a very, very high rate of speed. They're climbing at very, very, very fast speeds. So those two things together really do put kind of an exclamation point on that 7.1% and how steep it is. Here's one of my favorite views of another Tour de France. This is on the descent now, but there's also similar ones on the ascent. This is Alpe d'Huez. They call it the moon climb because when you get to the top of these climbs, it looks like on the surface of the moon, there's no vegetation up there. But you can see this is an 8% grade through this switchback right here. But imagine what it would be if you went straight down. I mean, imagine that. Imagine if you went straight from where this guy is here to where that guy is right there. What would that grade be? And we're going to show you how we did an approximate grade in class together, and we'll do it again here in a second on the next slide. But needless to say, it would be much steeper if they built the road straight down the side of the hill versus switching it back like this. It would be much, much steeper and also much, much, much less safe because these roads do get snow. All right, back to America. We are now in San Francisco. This is Sununknown Street. I claimed it was a 19% grade. I want to see if I can convince you why I said it was a 19% grade. So what I'm going to do is I'm going to zoom this in, and I'm going to take a screenshot of two of these doors. I'm going to go here to here. Whoops, I let go too soon. This is that snipping tool I taught you how to use on that last tech assessment. Here, we'll just do this. This will be a good start. Okay, I'm going to fire up. This will be very, very ghetto, but I think we get the we can make it work for our purposes, and that's about as good as I'm going to get zoom-wise in Paint. So what I'm going to do, if you look at these doors, you can see from the door itself, you actually get a pretty good idea of the grade. I mean, here's a step. There's a step. There's a step. So what I'm going to do is I'm going to draw, as well as I can on this little ghetto picture, the grade. So there's, let's see, do I want to come all the way over to here and then drop to the door? I think I want to come to here. Yeah. And then I want to drop with the next line down like this. And that essentially gets me the step. And then I come across, step, come across. Yeah. So that right there, I can zoom in on that now. That right there is kind of the grade of the road. I mean, it's rough, it's ballparky, but it's definitely an idea. Now we're going to do like we did in class last time. I'll change the color. We're going to call this, I believe we called it a Dorian. So we're going to call that a Dorian. That's one Dorian. I'm going to copy that and paste it. Whoops. I'm going to, excuse me. I think I hit the wrong button. I'm going to copy a Dorian. I'm going to paste a Dorian. I'm also going to rotate the Dorian so it's 90 degrees. Now I'm going to lay these on the run. That's one Dorian. I'm going to copy and paste again. Put them end to end best I can. Make it transparent. That's not going to let me, so I'll have to eyeball it. There's two. Here's three. Here's four. And 4 is going to be about here. And then a little bit less, maybe 4.5. So I got like 4.5. So I got one Dorian on the height and 4.5 on the rise. So a rise of 1 and a run of 4.5. I'm going to go back to my little window here and do 1 divided by 4.5. And I get a grade of 22%. So when I did this calculation the first time over here on the actual PowerPoint, I put 19. This time I got 22. It's probably all due to the fact of how precise or how imprecise I drew, but they are definitely within the same ballpark of each other. 19, 22%, right around 20%, somewhere in that neighborhood. So that's a pretty steep street. That's a pretty steep street, but San Francisco has plenty of steeper ones. This is Lombard, one of the more famous ones. It's 28.7 with the switchbacks. With the switchbacks, imagine without. The craziest one in San Fran, though, is Filbert. Filbert's a 31.3. It's so steep, actually, you can see they actually put steps in the sidewalk because it would be too unsafe to walk up and down. Not that they get snow in San Francisco, but they definitely get rain, and that's probably, since it's shady, pretty mossy. So I'd be worried about sliding down that puppy dog in that respect. Let's leave America again and go visit the crazy Kiwis in New Zealand. They actually built a street called Baldwin out in Dunedin with a grade of 35%. And this is just, I have to stop at this point and we have to do a quick little Google search of Baldwin Street, New Zealand, because it's insane. Do some images, sir. There it is on the map right there. There it is. Can't tell steepest street in the world. That's not true, but they can call it that if they want. Here's some wonderful images of Baldwin. That's looking up, obviously, at the steep part. This is a lady looking down from the steep part to the rest. It does the same thing Juniper does. So it's got a flat section that then amps up. This is a fun shot. This is where they took a house on the street and tilted it so the street looks flat and the house looks crooked, but that does give you it gives you an idea of how steep this street is. I mean, if you take a look at this, this looks to be about a third as big as this. And that's essentially, if you look back at this grade, that's what this grade is. It's about a third, right? I mean, 35% is almost 33.3333. So that's about, it rises 1 for every run of 3. It's very, very steep. But the Kiwis do not have the steepest street in the world, because I found one steeper, and it's not in California, and it's not in Seattle, it's not in Oregon, it's not in anywhere you'd think it is. Well, maybe it would be, depends on where you're from. It's in Pittsburgh, Pennsylvania, and this is Canton Avenue, clocks in at 37%. This is, I believe, the steepest paved road in the contiguous 48 states. It's not even paved, it's cobblestones, which is insane because they have a cyclocross bike race up it every year. Look at this guy's face. Look at the agony. Crazy. Totally insane. Totally insane. This guy. Forget my bike. I'm going to take my shoes off. I'm going to run up next to you. And they're just laughing at him, which I think is fantastic. So, yeah, Canton rocks in at 37%. These guys in the back staring at him like, nope, no thanks. Imagine coming down this and turning left. I don't even want to think about it. And there's snow on the ground back there because it's Pittsburgh. It snows in Pittsburgh. So, completely insane, but nonetheless, something I want to do before I die. This is just a stupid picture I found that I think is photoshopped. I'm not sure if it is. It's somewhere in Florida, and the biggest question I have is, if you actually drove your car down here, what would happen when you hit the sidewalk? Wouldn't your bumper hit before your front tires? I think it might. Anyway, so that's how you calculate grades over short periods. Like, for example, Baldwin Street is 35% right here. Filbert is 31.3 right here. My street was 20% right there. But what I want to talk about next in the next video is, how about when you have a distance like this? This is my commute this morning. So I went 6.1 miles. My house is over here, and I work up here at COCC. I climbed 709 feet in elevation over that 6.1 miles. Now, the difference is, if you look at my elevation profile down here, you can see what happens. I start at about 3,400, and I end this one up at about 4,000, okay? But you can tell that my elevations here are pretty stable. I'm not really going anywhere. I'm climbing out of my neighborhood a little bit, then dropping in, then rising up a little bit right here as I climb onto the butte. Then I drop right here. This is when I drop into Archie Briggs. So right about here is where I'm crossing the river right there. And then I rocket up Archie Briggs, and somewhere, I forget where Mount Washington happens. I climb up Archie Briggs, get onto Mount Washington Drive right here. And I'm not exactly sure where that is. It's probably somewhere around here. And then I drop again, and then I climb the last bit up to COCC, and then I drop back in when I get to the office. So the question really is what's the grade here? I mean, there's different grades, right? There's a much steeper grade here. Heck, there's a negative grade right here. There's a negative grade right here because I'm going downhill. But what's my overall grade? And I want to talk about that next with you when we get to the next video. So let's hang tight, and we'll regroup at the chalkboard.